So we're talking limits again. You can call these numeric. Okay, my writing is terrible with mouse. Some people call them tabular because we're going to use a table with numbers in it. Like I said, we've done this before. So it shouldn't be a reach for you. We just didn't call it a limit at the time because you didn't know that word. So let's just do a couple examples. I think you'll get it and we're good to go. So we're going to look at the limit as x approaches 0 of 1 minus cosine x over, I think it's x squared. We're in calculus now. So make sure x, your mode and your calculators are radians. And so next year you won't have to worry about, if you're in calc, you won't have to worry about changing from degrees to radians. This year we do because there's a trait component. So, okay, what's the first try? Plug and chug, huh? What's cosine of 0? Zero. This is 0 radians or 0 degrees. What's the value of cosine? Those are all angles. This is the angle. So if you're looking at your unit circle, 0 degrees. What's the cosine value? 1. Okay. So 1 minus 1 is crap. Now I can figure something else out. Right? So again, always try that. Sometimes it works. Can I factor that? No, I can't. So there's one more method you can use. It's called solving a limit numerically. Okay. And basically what it involves is getting really close to 0 and seeing where things are headed. So I don't even know what the graph of this looks like, but it's not too bad. Okay. Somewhere in this range, I don't know where the graph goes, there's going to be a hole at 0 because it's right, indeterminate. It could be an asymptote, but for the sake of argument, if I'm approaching 0 from the right, I need to create a table. It's going to start to look familiar. What's a number really close to 0 from the right? Point, right? What's a number kind of close? And then a number a little farther away. So you can see we're starting out a little farther away and moving closer and closer to 0 from the right, correct? What are the numbers on the left going to be? So if we're coming from the left, is that what you said? I heard mumbling. This is where these problems do get a little bit tedious. But there are a couple things you can do to make it faster and easier on you. Because we're going to use a calculator. You can do that in your head. You're a smart person. You know more about math than I do in this respect. So I'm gonna start with the largest. How many spaces does this one occupy? I'm gonna start with that one. And I'm just gonna kind of work my way down. So 1 minus cosine negative 0.001 divided by negative 0.001. Always use the biggest number first. Not the largest in value, but the longest. It is squared, actually, and I should probably put parentheses down there. Thanks for that. That will change the sign. Make sure your top is in parentheses so that you get that 1 minus cosine. Pretty sure I'm already in radian though. So 0.4999996. Where do you think this is headed? Well, probably. Okay. Well, we're gonna make sure. Because sometimes this side does something different. Okay. Sometimes this bounces around. So we need to check all these values. Here's how you make it easy. You've done your first entry, right? Second, enter, brings it back, and all you have to do is delete the negative or delete one of the zeros. And you have your next number already entered for you. This one is delete. My negatives, it's just the way I do it. Hit enter. Oh, look at that. Use your next number. Just repeat the process. I go to this one next, then I go to this one, and I just bounce back and forth. So I'm done. It's just faster that way. Okay. So I'm assuming it'll be 0.5, but we got to make sure it doesn't bounce, because you know what sine and cosine do? They do this, don't they? So we got to make sure this isn't bouncing around. So second entry, delete 0. All right, yeah, it's looking pretty good. It turns out that you get the same thing here. And then for this one, you're good. Okay, so what are we going to? All right, so this is going to 0.5, and so is that, correct? Yeah. So we can safely assume that this is going to 0.5. So I would write the limit as x approaches 0, 1 minus cosine x, x squared. 0. Okay. Just to be very clear, that's what I think. Just to be very clear, there's a hole at 0.1, at 0, 0.5. Right, x is 0, y is 0.5. We know the graph heads that direction, we know there's an open hole. Okay, so something like that. That's what the limit does for us. What? numeric limits are tedious, yes, but they help. Very rarely do we encounter them, but they do help. A lot of times numeric limits come to play when you have natural logs, cosine and cosine and stuff like that. I'll just show you this one just because there's another way to do it on the calculator. You might like it. So what do I do first? Plug it in. What's natural log of 1? Yeah. Ah, crap. Okay. Now we gotta have some fun, right? Can I factor it? Can I do anything algebraically? Can't. It doesn't do anything for us. So, okay, here's my x value that I'm headed towards. So let's something just to the right of it. That's good enough. It's the same pattern every time. Add 0.01, subtract 0.01. This is going to be be careful, some people will just make these negatives. I've seen a lot of negative 1.001 right here. That is not directly to the left of 1, so be careful. All right. Method 2. We are going to put this in y equals this time. ln of x divided by. Make sure you put parentheses around the bottom, otherwise you won't be the right answer. Here's one. Graphically, what do you think it's going to go to? Yeah, probably. Your calculator doesn't show a hole, but if you look at the graph, that's probably where we're headed, right? A couple ways to solve this problem. I need to go to 1.001. So if I go to calculate, you can see that I can calculate a value. Just like we can do zeros or mins or maxes or intersections, there's a value calculation here. Enter, and I'm going to put 1.001. And I get my y value. 0.999. I can do that, I just keep doing it. Second, calculate value, my x is 1.01. And you just keep going. This would be 0.95. These would mirror. And we do in fact see that it goes to 1. This is the graph that indicates. Okay. So the limit x approaches 1, ln. Second way to do it. You can also use the table feature in your calculator if you want. Doesn't matter, but just a couple ways there to do it. All right. Are we good there? Think you can handle those? let me just address one thing. Sometimes you're gonna run into graphs that don't just have holes. If I give you some function and it looks like this. Change myself. Let's say this is -10. This is what do you think's happening there? What's happening with this one? Is it growing in negative numbers? So it's most, if I'm approaching 0, I'm doing this number. What's happening if I'm coming from the right? Doing this number. Does that limit exist? No, it doesn't. So I would say this. Sometimes, if they do not go to the same location, this limit does not exist. They're not going to the same spot. This was going to the same spot. So is this. So just be aware. I don't know if that's going to come up or not. I just want to make you aware of that. Okay. So, good. Be right now, work. The SCR work on it.
I have mixed them up, so don't always assume it's going to be a numeric solution. And then I gave you the spiraling yesterday, but I'll write it down again. Hopefully you started on it. Are there any soccer games or anything tonight?
Yeah.
How many of you are in soccer? About track meets. Nothing tonight. Whoops.